From Schrödinger's equation to quantum conspiracy. My name is Ann Yu. I am the narrator for these slides by Professor Francis T.S. Yu. Here is Professor's presentation in his own words. It is a pleasure for me to give this presentation about this revolutionary topic. Before I get started, I would like to make a couple remarks. First, a scientist's dilemma. Should he bury himself within the timeless science and thrive, or should he change to temporal science in light? Second, as a learner, we gradually lose independent, logical thinking and opt to accept the approval of others. This slide shows the derivation of Schrödinger's equation as from Hamiltonian classical mechanics, from which we see that a particle in motion is situated on an empty space of a piece of paper as shown in the diagram. Total energy of a Hamiltonian particle in motion is equal to its kinetic energy plus the particle's potential energy as shown by this equation. H is equal to p squared over 2m plus v, which is the well-known Hamiltonian operator, where p and m represent the particle's momentum and mass respectively, and v is the particle's potential energy. Nevertheless, it is a non-physically realizable paradigm, since substance and emptiness cannot coexist. In view of preceding Hamiltonian operator, the Hamiltonian equation can be shown as given in this slide. H is equal to the negative of h squared over 8 pi squared times m times del squared plus v, where h is Planck's constant and v and m are the mass and potential energy of the particle, and del squared is a Laplacian operator. By virtue of energy conservation, Hamiltonian equation can be written as shown in the slide. H phi is equal to the negative of h squared over 8 pi squared times m times del squared plus v, all times phi, which is equal to E times phi, where phi is the Hamiltonian wave function that remains to be determined. E is an energy factor which is to be assumed, and V represents a potential energy that needs to be incorporated. This slide shows how Schrödinger's equation was developed. Since Schrödinger's quantum mechanics is the legacy of Hamiltonian, by adopting Bohr's quantum jump state energy, E is equal to hv from Bohr's atomic model. This shows on the left-hand side of the slide, for which Schrödinger's equation is given by the right-hand side equation. This slide shows where the non-physically realizable quantum leap comes from. It comes from Bohr's atomic model, which was presented within an empty space, as shown by the figure on the left-hand side, in which we see that there is a Bohr's atomic model, which is embedded with an empty, timeless space. But my question is, 1. How can quantum leap radiate since Bohr's atom is embedded within an empty space? 2. Yet in reality, Bohr's atom is embedded within a temporal space. Then quantum leap radiation has to be temporal t is greater than 0, which must be a time and band limited wave function and exists only in the positive time domain. In other words, t is greater than 0. In view of Schrödinger's equation shown in this slide, we see that it is a point singularity deterministic time-independent equation. That means it is timeless or has no time. This is virtually identical to the Hamiltonian equation, except the energy factor is E is equal to hv, quantum state energy of Bohr. The reason why this is a time-independent equation: firstly, Schrödinger's equation is the legacy of the Hamiltonian, which is a timeless classical mechanics. That is, it is time-independent. But Hamiltonian was derived on an empty space platform, as has been shown in the previous slide. Since Schrödinger's equation is a legacy of the Hamiltonian, Schrödinger's equation is a timeless equation. In other words, t is equal to 0, as based on the empty space platform. Nevertheless, major differences between Schrödinger's mechanics and the Hamiltonian must be the namesake of the quantum, which comes from Bohr's atomic quantum leap, E is equal to h nu, or a quanta of light that Schrödinger used for the development of his quantum mechanics. This is precisely Schrödinger's wave equation, which is very similar to the Hamiltonian as shown in this slide. Phi times t is equal to phi 0 times the exponential of minus 2 pi nu times t minus t0 over h. This is the Schrödinger wave equation, where phi 0 is an arbitrary constant, nu is the frequency of the quantum leap, and h nu and h is Planck's constant. But this is a non-physically realizable equation, since it is not a time and band limited equation, and it is also not temporal. T is greater than 0. That is, it exists only within the positive time domain. Since all the multi-quantum leaps are not time limited, it is trivial to see that all their quantum leaps will be instantaneous. These quantum leaps are not simultaneously superimposing at all times, and they are not simultaneous events within our temporal universe. However, it is possible to reconfigure a non-realizable wave function to be temporal, which is t is greater than 0, as shown in this slide. Phi of t is equal to phi 0 times the exponential of minus go 0 times t minus t0 squared times the cosine of 2 pi nu t, comma, t is greater than 0, in which we see that it is a time-limited Gaussian wavelet that exits in the positive time domain, as shown in this slide, which can be implemented within our temporal universe. T is greater than 0. This slide shows Schrödinger's fundamental principle of superposition as stated. Every quantum state can be represented as a sum of two or more other distinct states. Mathematically, it refers to a property of solutions to the Schrödinger's equation. Since the Schrödinger equation is linear, yet timeless t is equal to 0, any linear combination of solutions will also be a solution. In short, Schrödinger's superposition principle is that multi-quantum leaps are simultaneously and instantaneously superimposing in space and in time. This slide shows what timeless t equals to 0 space can do to particles. Although timeless t equals 0 space is not a physically realizable paradigm, since emptiness and substance cannot coexist, that is temporal exclusive principle, but quantum physicists can implant particles into an empty space, since quantum scientists are also mathematicians. This slide shows what empty space can do to particles, for which we show two isolated particles are embedded within an empty space as shown on the left side diagram. Firstly, we see that it is not a physically realizable model, since particles cannot exist within an empty space. Secondly, since empty space has no time, we see that particles are collapsing at t equals 0, as can be seen on the left-hand side diagram. Since empty space has no distance, we see that particle 1 and 2 are superimposing together over the entire empty space as shown on the right-hand diagram, from which we see that this is precisely the fundamental principle of superposition that Schrödinger stated, from which we see that Schrödinger's superposition principle only existed within a timeless space, which is t is equal to 0, and an empty space, which cannot exist within our universe. Nevertheless, empty space has no time and no distance and no space, from which we see that empty space is a virtual mathematical space. It is not a physically realizable space, and it cannot be an inaccessible space within our temporal t is greater than 0 universe. This slide shows what temporal universe does for time-limited quantum state wavelets. For example, we have two temporal quantum state wavelets as shown in this slide, wavelet 1 and wavelet 2 as given by the respective equation, as shown in this slide. Since there are time-limited temporal wavelets which can be implemented within the temporal universe, t is greater than 0, from which we see that these wavelets are not superimposing within our temporal universe, t is greater than 0, as in contrast with the fundamental principle of superposition which has been predicted, from which we have proven that Schrödinger's superposition principle is not existing within our universe. This slide shows what empty space can do to quantum wavelets. Again, we have two time-limited quantum wavelets as shown on the left-hand side of this slide. If these two wavelets are plunging within an empty space as illustrated on the right-hand side diagram, firstly, we will see that these two wavelets are superimposing together and collapsing at the same time, t is equal to 0, as can be seen on the right-hand side diagram. Since it is a timeless t is equal to 0 space, it has no time and no space, for which we see that superposition exists only within an empty space, and it does not exist within our temporal universe. This slide shows what happens to particles existing within our universe. For example, we assume particle 1 and 2 are plunged within a temporal space as shown in the figure. We see that they are precisely located at their specific locations within a temporal t is greater than 0 space, since the temporal space has time and distance. One condition I stress: particles in motion or static are a temporal particle that change naturally with time, in which we see that Schrödinger's superposition principle fails to exist within our temporal t is greater than 0 universe. It is interesting to see what happens if these particles are plunged within an empty space, although it is not a physically realizable hypothesis as depicted on the right-hand side, from which we see that particles lose their position identities by superimposing at time t is equal to 0. Once again, I have proven that superposition principle exists only within a magical, virtual, timeless space, that is at t is equal to 0, but not within our universe. This slide shows two time-limited multi-quantum wavelets existing within a temporal space of t is greater than 0, from which we see that superposition fails to exist within our temporal universe of t is greater than 0. Since within temporal universe, it has time and space. Let me stress that within our universe, everything has a price to pay, a section of time, delta t, and an amount of energy, delta E, or space. But it is the section of delta t that we cannot squeeze to 0. In other words, delta t equals 0. But it can approach 0. In other words, delta t can approach 0. This is causality or temporal constraint of our universe. T is greater than 0. This slide shows our universe started from Big Bang creation, changing naturally with time. It shows the age of our universe is about 14 billion light years old. It shows past time domain, t is less than 0, is the certainty virtual image, which has no physical substance and time. Future time domain, t is greater than 0, represents a physically realizable, uncertain universe, which will have both time and substances. While the present, t is equal to 0, represents an instant moment of absolute physical reality of our universe, which has both time and substance, in which we see that past universe had to have changed with time. Thus we see that time can be treated as an independent variable. Future universe will change with time. This means time is a dependent variable. Present universe, t is equal to 0, is an absolute moment of physical reality. Therefore, it is a mistake to treat our temporal universe, t is greater than 0, as a four-dimensional space-time continuum, as most scientists do, because time and universe coexist. My conclusion is, since quantum supremacy depends on Schrödinger's fundamental principle of superposition, as I see it, the timeless principle has emerged as a worldwide conspiracy. It is a quantum conspiracy. Thank you very much for listening to my lecture on quantum conspiracy.